Ladies and gentlemen, good morning. Thank you very much for inviting me to this conference. I will not be talking to you about science or technology or CSP, just at the very end of the presentation. I will be talking a little bit about policy and policy, energy and climate policy related to Cyprus, because all socioeconomic modeling and work has to take into account national particularities. But several of these aspects are relevant both for all European countries that are subject to the same commitments, but also to any country that would be seeking decarbonization strategies for the coming years. So, of course, we know that deep decarbonization by the middle of the century is very challenging for almost any country of the world. We had the European Commission's communication some days ago about the target to achieve climate neutrality by 2050, which makes things even more challenging. So the background is that if we are serious talking about economy-wide decarbonization, we need to think about interventions in all economic sectors, in fact. And of course, we know, and you will be talking about these aspects, and you are working on these aspects as researchers on power generation, on achieving zero carbon power generation. It is, of course, crucial, but if we are talking about economy-wide decarbonization, obviously it's not sufficient. So what about the fuel that we use not to produce our electricity, but all others in all other sectors? That is transport, industry, all our buildings, agriculture, and so on. These are also challenges which are important. And talking in a European context, where we are talking about the emissions trading system, the ETS system, and all other economic sectors that are not subject to emissions trading right now, the non-ETS sectors, we know that decarbonization, especially in the non-ETS sectors, is very, very difficult. This is the target for Cyprus. Each country, each EU member state has a different target, which may be almost equally challenging to each country. So the target for Cyprus to reduce its greenhouse gas emissions in the non-ETS sectors, that is light industry, buildings, transport, and agriculture, is 24% reduction compared to 2005. That's a huge reduction required. And if we take into account that more than half of these emissions are coming from road transport, and road transport globally is the sector which is resistant to decarbonization because it is still almost entirely dependent on petroleum fuels, then of course this gives us an overview of the magnitude of the challenge ahead. So of course we need substantial improvements, and that's probably an understatement, to reduce both the use of cars, car travel, and also to reduce fuel consumption of cars. And that's a point that I will be coming to back in the end. To do this, you don't only depend on technologies, you need the whole economy to be directed to the target to achieve a low carbon future. And of course, the national tax system is very important for this. So I will briefly touch upon three aspects, if I have the time, which are based on individual studies that we have made in the recent past and which are one way or another interrelated. First of all, about how much energy efficiency measures can contribute to these economy-wide decarbonization objectives. Secondly, what about further policies and measures in the non-ETS sectors? So apart from power generation and heavy industry, how cost-effective are they, and which ones should we prioritize? And then perhaps rethink the issue of our taxation system and to what extent this can contribute to achieving a low carbon economy. So let's start with energy efficiency. This is now a new motto of the European Commission, energy efficiency first. So the first fuel, as the International Energy Agency has said some years before, because energy savings can be can contribute very much to emission savings. So we tried to assess recently under funding from the European Commission and the German Ministry of Economy and Energy to assess the maximum theoretical potential and the economically viable potential for energy efficiency measures in Cyprus, with emphasis on buildings and industry. Transport was the subject of a different study, which we were not involved in. That's why I'm not mentioning it here. So to do this, we employed an engineering model to assess the maximum energy saving potential in buildings and industry, meaning conducting a detailed dynamic simulations of the energy demand in different types of buildings and so on. We collected economic data for different energy efficiency interventions in all these sectors. We took into account, because it had to be a policy relevant work, so we had to take into account realistic constraints, both as regards finances and also technical constraints for achieving such objectives. We constructed different cost effectiveness indices on the basis of our modeling results and the economic data in order to have multiple views on which policies we should prioritize. And then we provided a ranking of the potential interventions that could be exploited by authorities. Then we incorporated these results in a long-term energy model for energy demand in Cyprus in order to find out to what extent these efficiency measures could contribute to the targets of 2030 and 2050. The targets of 2030 are related also to energy efficiency, EU-wide, and the targets for 2050 are the broad decarbonization targets. So we explored the theoretical absolutely maximum energy saving potential, and then what we called the economically viable, the realistic energy saving potential in buildings, in the residential and commercial sector, and in industry. As I said, transport was left behind because it was the subject of a different study. So what would be the theoretically maximum potential? Where we, in agreement with the energy authorities of Cyprus, we arrived at this definition that the theoretical potential should be the amount of energy consumption that can be saved if all existing residential building stock is renovated to nearly zero energy buildings. And of course, we try to identify the potential savings in heating energy, in cooling energy, in the energy used for domestic hot water production, and of course in electricity. And we assume the gradual penetration of specific technologies that are very promising in terms of achieving very high efficiency figures, where the structure of the model is not of particular interest. We made a very thorough review of the existing building stock of Cyprus, so we could distinguish between different building types, different ages of buildings depending on construction period, and 3 different climate zones of Cyprus. And we conducted dynamic energy demand modeling simulations for each one of these building types, with and without renovations. Anyway, the result of this would be that the theoretical maximum energy saving potential in the current building stock, and we're not talking about the very new buildings that have to comply with stricter energy performance regulations, could reach something around 60% of savings. The full renovation would mean that you would eliminate all use of gas oil, so diesel, heating diesel, and kerosene, which is also a version of heating diesel. You would reduce the use of biomass, and you would only use LPG for some heating purposes. And of course, you would move to electricity because of the very highly efficient heat pumps right now. So 60%, just a number to remember, as the maximum theoretical saving potential for buildings, for existing buildings. But then, of course, we had to take into account the economically viable potential, because to renovate all these buildings would require a few billions of euros. So over a period of 10 years, you would need to spend something of the order of the national GDP of the country. So that's, of course, not realistic. It was just a benchmark. So for about the economically viable potential, we had to rely on more realistic measures that could be performed relatively easily and at relatively low cost. And we had a total budget constraint, we could say, which had come from earlier studies, that total expenditure in residential building renovations should not exceed around 500 million euros up to 2030. So the country's GDP is 20 billion euros, around 20 billion euros. So 500 million euros would correspond to something to about 2.5% of national GDP. We had a similar budget constraint of another 500 million euros for commercial sector buildings. So overall, this is not a negligible amount of money for both public and private investments. But of course, the result, if we take into account these realistic constraints, would be that compared to the 60% figure, we would have to come to around 6% energy savings. So this gives us an impression of the order of magnitude of the interventions needed if we need to talk about deep decarbonization. Now, as I said, we did the same with the industrial sector and with commercial buildings, and then we fed this into an energy demand forecast model to see how the future energy demand, taking into account, of course, macroeconomic and oil price projections and so on, how this would develop in the case of a business as usual development, or in the case of a realistic scenario, or of a scenario where all theoretical energy saving potential would be exploited. And of course, this is the aggregate figure of total energy demand. I'm not going into the sectoral forecasts. And of course, it seems that given the forecasts of economic output in the future years and the forecasts of energy prices, the only case where total energy demand would start and continue declining, but not to the extent that we would need for deep decarbonization, would be under the maximum technical potential scenario. So the realistic scenario would just bring about a stabilization of total energy demand. Of course, this very much depends on what you assume about transport, which I have not touched upon. Of course, if we observe the evolution of energy demand per unit of GDP, so what we usually call energy intensity, of course, there will be a continuous decline, or irrespective of scenarios. But you see that even this very ambitious decline in energy intensity is the one that, in order to be feasible, would require very high investments. So the preliminary conclusions as regards energy efficiency measures would be that, of course, we can substantially increase the energy productivity of our economy, especially in the households and services sector, and of course in transport. But of course, we certainly cannot continue along a business as usual path. We should even not continue under a business as usual plus path. We need something more radical, and this is very relevant for almost all EU member states, and I'm almost sure that this is very relevant for any other country of the world that has the objective of deep decarbonization. Of course, for a transition to a low carbon economy, we would have to tackle road transport very aggressively. And of course, in order to do this, we would need some smart financial tools and a green tax reform that I will come back to in a while. Now, this is regards the energy efficiency. Now, if we want to expand the scope of our work and think about emission abatement in all non-ETS sectors, not necessarily only energy efficiency measures, but other measures as well that would be related to switching of fuels or things related to agriculture and so on. We had a second study that we did, again under funding from the European Commission, on the cost effectiveness of different climate change mitigation measures. So we considered economy-wide policies and measures to reduce greenhouse gas emissions, again with a focus on non-ETS sectors. So we excluded power generation and we excluded the limited heavy industry of Cyprus, because that's what we were asked to do, but that's also in line with our approach that we need to see what has to happen in non-power generating sectors, because we more or less know what is going to happen in power generation or what is required to happen. So we identified a number of policies and measures to reduce greenhouse gas emissions in all sectors of the economy, and we employed nationally relevant engineering and economic information about each measure, and then we assessed each measure's cost and the corresponding emission abatement potential. And in this way, we could construct what one would call a marginal abatement cost curve, meaning a curve like the one that I will show you in a while. So this is a list of the measures, perhaps a non-exhaustive list of the measures that we considered in the residential sector, in the services sector, in industry, in road transport, and in agriculture. So we are going a little bit beyond simple energy efficiency measures. Of course, most of the measures in the residential and services sectors in buildings are energy efficiency related. But of course, we are talking also in the industry about replacement of different equipment that could again move towards more efficient equipment, and also industrial cogeneration in industrial plants. We included cogeneration in the services sector, meaning mainly cogeneration in hotels and hospitals, where there is a realistic potential for cogeneration of both electricity and heat. In the case of agriculture, we considered mainly the increased use of anaerobic digestion for animal waste, which would reduce methane emissions and at the same time would lead to cogeneration of electricity and heat. This already happens to some extent with the waste of some pig farms, but this could be expanded quite a lot more, but of course with quite some investment. And in the case of road transport, which is the most difficult one, we tried to think about relatively radical measures because simple measures cannot do the job. So a strong promotion of public transport, relatively realistic, but quite strong. The promotion of fully electric cars, or you could say even plug-in hybrids, but we mainly focused on electric cars and on CNG-powered trucks and buses. So we were not talking about just replacing the old fleet of some industries with a more fuel-efficient fleet. This can lead us nowhere. The decarbonization targets are so strong that we need to think about stronger measures. So we arrived at such a abatement cost curve, which you may have seen such curves before, which show for a number of emissions, for a given number of emissions abatement, what the cost would be in euros per ton of CO2 abated. And these rectangles correspond to the emissions abatement potential and the corresponding cost of each measure. So the most cost-effective measures have to do, of course, with energy efficiency interventions. So that's why this turns out to be a negative cost option. Negative cost options, in theory, would mean that an investor would immediately want to do this. So there are hidden costs, but of course, from a societal viewpoint, it is important to see that these are really measures that can bring benefits to society. So these would really be worth supporting with national funding schemes or international funding schemes. So the installation of heat pumps, for example, in residential buildings, or roof insulation here, the potential is not huge. The potential would be the size of the horizontal axis, but still they are quite cost effective. Cogeneration in hotels and hospitals in the services sector and cogeneration in industry are also among the measures that are worth doing. Anaerobic digestion is not costly, so it can already reduce greenhouse gas emissions at quite a low cost or perhaps negative cost. Of course, the transport-related costs are a little bit higher, but of course, it's only transport that can deliver large abatement. And that's still not enough, because we tried to assume some realistic replacement of cars and not an immediate replacement of all the passenger car fleet until 2030 with electric cars, for example. We wanted to be realistic, but we wanted to be a little bit ambitious. Now, of course, these are the costs. If we observe, the usual things, the investment and operation costs and fuel costs compared to the current situation, and then the abatement potential. But if we take the additional benefits from decarbonization, from energy efficiency measures, and from CO2 emission reduction measures, then the picture a little bit changes. If we take into account the costs of air pollutant emissions, so if we take into account not only the out-of-pocket costs, the monetary costs of an investment, but also the costs of reducing, the benefits, the avoided damages from the avoided emissions of nitrogen oxides and sulfur dioxide and carbon dioxide, then of course some of the measures become really more interesting. For example, if you see the transport measures can now be considered to be zero cost measures, because we have taken into account the additional benefits from the avoided air pollution damages. So this is an important conclusion. So we identified a number of appropriate mitigation policies, which we have listed here, and I will not go through in detail. But we have to be careful because the total abatement potential, the total size of the horizontal axis that we observed here, is still insufficient to meet this -24 target by 2030. So this brings us to the need to do something a bit even more radical. And that's why we are proposing, and this is politically extremely difficult, but we don't stop proposing, and there are some organizations and some trade unions and some ministers and some officers of ministries who are completely aware of this issue and support us, that we need to introduce a serious carbon tax in our non-ETS sectors. We're not talking about a carbon tax in emissions traded sectors because these are already subject to an implicit carbon tax through the emissions allowance system. Okay, and we made a proposal for a gradual introduction of a carbon tax over a period of 5 to 6 years, and I will not go through it in detail because there's no point doing this. This is the evolution of non-ETS CO2 emissions in line with the evolution of energy consumption that I showed you before. And the green line shows what would be the difference with the introduction of a carbon tax. Is it sufficient to meet the -24% in 2030 compared to 2005, which was about here? No. But of course, there's no single measure that can do all the job. But without having the tax system encouraging energy conservation and reduction in emissions, and then bring technological incentives on top of that and technological progress on top of that, we cannot achieve deep decarbonization. So our overall conclusions: energy efficiency is very important, and we need to take care about this. There are many barriers to serious energy efficiency investments. They are recognized, and we are going on with this. All international and national institutions try to promote serious energy efficiency investments, both by the public and private sector. And we need to take into account that such investments have multiple benefits because of improved air quality, because of decreased fuel imports and not increased, the point that you made as well in your previous presentation. Adaptation to climate change. I mean, if you have incentives to have an insulated building, then this protects you from an even higher temperature. So it's also an adaptation measure that can be encouraged through energy efficiency improvements. So the financially realistic abatement potential is substantial, but it is inadequate to meet the deep decarbonization objectives. That's why we would need a green tax reform, which would primarily consist of a serious carbon tax without increasing the total tax burden to the economy, to households and enterprises. A carbon tax with reductions in other taxation, for example, in labor taxation. This is something that has been applied in several countries. And that's the motto of this economy-wide idea of tax. Tax what you burn and not what you earn, because what you earn is beneficial for economy and for the society. What you burn is probably not. These are the overall conclusions. I will finish just with some information provided to me, which is very relevant for your conference, but I'm ignorant about the topic. By a colleague, it was provided to me by a colleague of mine who could not be with us today because he's in China, Professor Sotiris Kalogiru, who is working on solar energy. So that's a new project that is starting, and it is funded by the National Research Foundation of Cyprus and some German sources on the evaluation of the dispatchability of the parabolic trough collector system with concrete storage. And this is something that will be tested. This is the installation, so you are more familiar with me about this than me about this. These are the collectors. So this is the concrete storage probably, which is somewhere over there. This is installed in a factory in Limassol which produces juices. And these are some quantitative details. So this seems that it has been installed right now. And these are the partners of the project, the Cyprus University of Technology, this firm, and DLR, and the Solar Institute of FH in Aachen. So anyone interested can contact my colleague Sotiris Kalogiru for more information about this. So I tried to bring this in order to pretend that my presentation was relevant to your research interests. Thank you very much.
Thank you, Theodoros. That's really comprehensive. Are there any questions for him?
In Italy, we have a lot of subsidies for carbon, say for fossil fuels that are less evident than the subsidies for renewable energies. So what about killing them before going to a carbon tax? That would be quite better, I mean, to just starting from taking them away. Which is the situation in Cyprus?
You're absolutely right. And your environment ministry has recently published a very nice report about environmentally harmful subsidies in Italy. And you're right, there are so many hidden subsidies. We are talking about subsidizing, CSP or photovoltaics. And we don't consider that there are many indirect subsidies. For example, all fuel used for power generation is exempt of excise taxes. Isn't that a subsidy? That could be a huge subsidy. Of course, agriculture is even more politically challenging. We try to identify these environmentally harmful challenges, subsidies for Cyprus, but that was too specific for this presentation. They are not that huge because we don't have a local fossil fuel industry. So of course there are subsidies, even water is subsidized, especially for agriculture. The exemption in the excise tax of fossil fuels for power generation is important, and we estimated the amount of the subsidy and how much eliminating the subsidy the electricity prices could increase. Of course, in order to have a level playing field, you would need to take these into account. But of course, some of these subsidies, have been adopted for reasons of rural development, social equity, although they may not be that equitable after all. So they are politically difficult to reduce. But of course, a green tax reform would need to tackle these, and perhaps before talking about putting an additional tax. But my point on the carbon tax is that you can do it fiscally neutral, as finance ministers would say. So by reducing other taxes, if you don't have deficits, you don't need to increase the tax burden to the economy. You can increase taxation on environmentally harmful activities and reduce labor taxation or income tax or VAT. But labor taxation would be, I think, more relevant in times of relatively high unemployment.
Yeah, but for public opinion, let's say, I would say that it's better to cut a subsidy than to put a tax.
Not always, perhaps, because if you cut the subsidies to power generation and this increases electricity prices, then is this more acceptable? You could argue about treating all power generators fairly, for example, and equally. But I don't know. It depends. And then think about water. But this is out of today's discussion.
Thank you, Theodoros.
Thank you.